Hey folks, in this video I'm going to go through the analysis for the force, mass, and acceleration lab. So if you want to do this with me, you can. I can also do this during class. What you will need is your handout for the lab with all of your data. You will need a you'll need a Google Sheet open up that you're going to use, and that's pretty much it. I will bounce back and forth. The first thing you want to do on your new Google Sheet is you want to type in all of your data. Exactly as you see it in the data table, and you want to put labels above each column in the order that they appear. So force and acceleration, and then mass and acceleration. You can put the units, because you should always put units on there. Those aren't going to be as important as the names of the variables themselves. So pause the video now and type in your data. Okay, to graph something on Sheets. By the way, I'm using Sheets because many students cannot access their Excel accounts. So on Sheets, you want to highlight your data. So what that looks like is click on force and drag until you've highlighted all your data. Then go to the Insert menu, click on Chart. Don't change anything. If you've typed this as I have, you will just get a graph. It has a title, acceleration versus force, and each of the axes is labeled. The title of the graph, Sheets does this automatically. Excel doesn't do this. The title of your graph, this is how I want you to title your graphs. You don't have to do this on your copy of Sheets, but the units are not as important. But the way that this title is laid out, acceleration versus force, that order tells me that acceleration is the quantity that should be graphed on the y-axis, and force is the quantity on the x-axis. It always goes independent variable, let me start again. It always goes dependent variable first, followed by independent variable. Anyway, so now you're going to set up a trend line for this graph only. So in the Customize menu, there's a submenu for Series. And if you scroll to the bottom of Series, you get a checkbox for trend line. Now, I made up my data, so mine's perfect. Yours will have a lot of variation in it. You can now scroll down and type in Use Equation. So at this point in time, you are going to sketch this graph. Sketching this graph is something that is a very specific set of instructions for AP Physics 1 and AP Science in general. When you sketch a graph, you should include only the following and nothing more. So you're not plotting points or anything like that. You are just showing me the shape and equation if needed. So what we're showing is this graph. Now pay attention to the equation for your line and whether the y-intercept is positive or negative. Mine is negative, and so you want to just like honor that value. All right, so you get a piece of graph paper. I did not successfully get graph paper, but you will. And you're gonna, on the front side of the graph paper, you're going to sketch your acceleration versus force graph. My y-intercept was negative. That means that my graph is going to intersect the x-axis before it intersects the y-axis. So you just draw a straight line. Now all of your data should be linear for this part, so everyone's data is going to be the same. Then you can put in your equation. Now it says x. X is whatever variable is on the x-axis, and it doesn't say y. Y is the variable on the y-axis. So I'm going to go back and forth. My equation is going to say, instead of y, it's going to say a, because acceleration is graphed on the y-axis. Slope and x variable, 2.13 times x. So my equation is going to be 2.13 times force, because force is on the x-axis. And then minus 3 times 10 to the negative third. Yours will probably be a bigger value than that. And that is your equation. So that's really just for reference. And this is a complete sketch. Notice no numbers except 0 and just the trend of the line. Okay, repeat this for the other set of data. So I'm going to scroll down. I'm going to highlight this data set, insert, chart, and I get a very different looking graph. Now, chances are excellent that your graph doesn't look as curved as mine does. That's because I made up data and I made it up wrong. on purpose. So with this data, you'll see what I do, but you need to do the steps for your own data, and you will get different results than I do. Okay, so what do you do with this? You make another sketch. This acceleration force graph goes on the top of the front page. The acceleration versus mass graph goes on the top of the back side. Now, this is a curved graph that has this like negative trend. You're not going to plot points. You're not going to use sheets to determine a trend line. You are just going to draw that trend. Keep in mind, that this point here is not actually on the y-axis. It's on a value of 0.2. Sheets is very bad at this and will rarely show you the y-axis unless you have a point on the y-axis. So when I go to draw my trend line, I'm going to draw something like this, and you're going to freehand draw a trend line for your own data. And that ends the first part of the graphing. So now we go to the handout. We did analysis 1. That was our acceleration versus force graph. We did our analysis 2. That was the acceleration versus mass graph. It says this graph will not be linear. Now we are going to use sheets to help determine what graph must be plotted to create a linear graph. Use the remaining column for your linearized data. So I'm going to show you how to linearize data. Basically, this graph of acceleration versus mass was not linear, and so we are going to make it linear. Now I'm just going to delete this graph. Oh, I guess I can't. I'm going to delete this graph. I'm going to move this one up so we can make room for it. This graph shows a negative trend. Now, when we look at our graphs, what we're determining here is what is the relationship between acceleration and mass. And what we're finding is that as the mass increases, we go from left to right on this graph, the acceleration decreases. Now, you might have learned this relationship as an inverse relationship. There are infinitely many inverse relationships because there are infinitely many powers that show us how mass behaves here. So what we're looking for is acceleration is related to mass to some power. The options for that power are generally plus or minus 1, plus or minus 2, or plus or minus 1/2. Okay, I say generally because in physics, in this physics course, these are the 6 powers that you generally encounter when you determine relationships between variables. The more physics you take, the more options there are. Okay, what does plus or minus 1 mean? That just means plus 1 is a linear relationship. Acceleration varies linearly with mass. That's not the case. So it is not plus 1. Plus 2 is your typical quadratic relationship. That would show an upward curve. It is not plus 2. Plus 0.5. Okay, 0.5 as a power is square root. That would be a parabola that opens to the right, and it is not that. So the possible powers for mass are -1, -2, and -0.5. It's generally pretty hard to eyeball these, so we use kind of the power of sheets to figure it out. So here's what we do. We're going to make a new data table. This new data table is going to be the same size as the other one. It's going to have all of the data for acceleration. So you can copy and paste the acceleration data into that table. The other one is going to be blank. It's going to be mass, but it's going to be mass to some power. And so we're going to figure that out later. Here's why Sheets and Excel are super awesome, in my opinion. What you want to do is you want to try, so this is if mass is to the -1st power. Basically what that means is if I were to graph all of these numbers to the -1st power, I might get a linear relationship, and that's going to tell me if I've done it correctly. So you're going to go and you're going to do mass to the -1. And then here's what you're going to do. So we're going to do math with Sheets. You hit the equal sign if you want to tell Sheets or Excel to do math. What I want to do is I want to take 0.2 to the -1st power. Now, I could do that really easily in a calculator, but I could also do it very easily in Excel. So I'm going to click on the number 0.2, and it puts in A14. That's the identity of the cell that the number 0.2 is in. And then I do caret, that's the exponent button, and then -1. So equals A14, that cell with 0.2, the negative first power. I hit enter, and it gives me the number 5. That's 0.2 to the negative first power. Now, on Sheets in Excel, there's a dot or a square that shows up in the bottom right-hand corner. If you click on that and drag to the end of your data table, it will then calculate all of the other powers that you need. So how do I prove this to you? Up here is the formula bar. So to get 5, it took cell A14 to the negative first power. This number 3.03 repeating. Okay, this took A15 to the negative first power. So just by like dragging down, it went to the next value in my mass column, and it calculated that number to the negative first power. It then did that for 0.47, for 0.88, and for 1.2. So that's a quick, easy way to make that work. I'm just going to clean up the number of sig figs here with these little decimal point buttons. All right, now I don't know if this is right, so I'm going to test it out. I highlight the data, I insert a chart, and I pretty clearly didn't get a linear graph. This looks like a quadratic relationship, so this is not a success. If your mass to the negative first power was a success, then you're done. And you can just like skip ahead until I'm done with this part and you see my my work out on the paper. So it didn't work out. So I have to go back to the drawing board, and now I'm going to try if m is to the negative second power. So I'm going to do m to the negative second power. So that first one didn't pan out for me. I'm just going to delete all my data. And I'm going to repeat that type of calculation, except I'm going to take everything to the negative second power. So I do that really quickly, and I regraph it. And look at that. This is a linear relationship. So this acceleration versus mass to the negative second power gives me a linear relationship. So real quick, I'm going to make a trend line, go into series, put a trend line in. I'm going to put the equation in, and it gives me the equation of the line. So I am now going to draw that on my sheet. So I go underneath my acceleration versus mass line, I make a graph with the data that I had. You have to be very careful here. Acceleration was on the y-axis. On the x-axis is whatever you just determined. Now for me, it is mass to the negative second power. It's hopefully something different for you. I'm going to write mass to the negative second power. Part of doing good physics is making sure the units are correct. Well, the units for mass are kilograms, which means that the units for mass to the negative second power are kilograms to the negative second power. That's not a real unit, but for the math that we're doing, it is consistent with the things we've done. Now I draw a line, and here's where the last part of thinking about this graph comes in. My equation is written here. So the slope is 0.9. The y-intercept is negative 2.73 times 10 to the negative third. You're going to write the equation of the line. Well, the y-axis variable is a, so a equals 0.9. That's the slope. Now comes the x-axis variable. The x-axis variable is mass to the negative second power. And then the y-intercept is negative that. So this is the equation for my line of best fit. And so that's how you do the graph straightening or linearization. You just try it until you get it. If you're not sure which one it is, just ask me in class, like make all 3 graphs, save them, and then just show me in class. That's it. So now we're done with the linearization, and we're going to go on to the rest of the analysis. Okay, so we've done all of our graphs, and now we're on number 4. On the bottom half of the front of the graph paper, write a separate proportionality for both data sets in the form of A is proportional to B to the X, where the two variables are. Okay, so here is where I do my analysis. Any graph that is linear is what we want. So only our linear graphs. A and F have a linear relationship. So I want to write A is proportional to F. Now technically that's to the first power, so I'm going to write that. And this is a linear relationship. As force increases, acceleration will increase by the same factor. Now I do the other one. Well, this one was A and mass to the negative second power. So those two are proportional. A is proportional to mass to the negative second power. So you, again, do yours the way that your data showed you, which is not necessarily what I have. And these are proportionalities. So we'll talk about what these mean more in class. But right now, it means that as you increase the mass, the acceleration will go up. As you decrease the mass, as you increase the force, acceleration goes up. As you decrease the mass, acceleration goes up. Next one, we're going to transform our proportionalities into a single equation relating force, mass, and acceleration. Step number 1 is to write them as a combined proportionality. So we're going to combine. And we're going to say A is proportional to force times mass to the negative second power. Now, if you remember your exponents, you can also do this as A is proportional to force over mass squared. But I'm going to leave it like this for now. All right. Next thing to do is going to be to solve this proportionality for force. Now, this is mostly just to like make it. Actually, no, we're not going to do that. We're going to leave it like this. Now we're going to turn it into an equation. Now, equations have equal signs. And equations aren't necessarily the same thing as proportionalities. So proportionality tells you like the way that the variables behave with one another. An equation actually tells you the mathematical relationship between them. So I'm going to put this letter K in. That letter K is called the proportionality constant. And this is just a number that makes the equation work. So if you actually plugged in acceleration, force, and mass values, the left side would be equal to the right side. With just a proportionality, that isn't the case. All right, so that's like the next part. The next thing that we do is we're going to solve for K. So at this point in time, you want to go to your data table and you want to pick one trial from one of your data sets. I would pick the third trial. It tends to be the most accurate because it's the middle mass and the middle force. If you didn't do yours in order, try and find the middle trial in terms of mass or force in one of them. And I'm just going to copy a trial from one of mine. So I have to like compile this. So we're going to have acceleration is 1.91. Force is 0.9. And mass is going to be 0.47. So you just have to record the acceleration, force, and mass from one of the trials. And then we have A equals KF times m to the negative second power. So 1.91 equals K times 0.9 times 0.47 to the negative second power. My calculator is not on my desk, so I'm going to pause this and calculate that. Okay, so you're going to calculate a value of K once you plug things in, and my value of K is 0.47. Okay, the units on that are something that you need to figure out. So I did not do a good job of that. I'm going to do that off to the side. So I can rewrite this as A equals K times F over M squared. If I solve this for k, I get k equals m squared a over f. The units of k are therefore kilograms squared times meters per second squared divided by, and a Newton is kilogram meters per second squared. So if I go through some unit cancellation, one of the kilograms cancels, the meters cancel, the second squared cancel, k has the units of kilograms. By the way, which is wrong. And so you want to do your own unit cancellations yourself. And so that is the value of k. Now, I ran out of room, and so you might run out of room, just go onto another piece of paper. But that is the equation, starting with the proportionalities. So I'm going to rewrite this in this form. And it's going to say A equals 0.47 kilograms times F times m to the negative second. The last task here is perform a percent error calculation between k and the one that you found in the accepted equation. The accepted value of k is 1. And so you're going to do a percent error calculation with that. I know this is a long video, but if you start this process on your own, you can easily ask questions when you're in class and get that done. So thanks for watching.